Hello guys, welcome to Bugs in Code, and today I'm going to explain you a very important algorithm which is KMP algorithm. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So without further delay, let's move to the problem statement. So this is the problem that I'm going to solve by explaining this algorithm. So the problem statement is something which says that given two strings needle and haystack, and return the index of first occurrence of needle in haystack, or -1 if the needle is not part of haystack. So this problem is present at lead code, and I'm even going to provide the link in the description box. Here one example is also given, so let me just explain the example. The example says that you're given an input which is haystack string str, and it is sad but sad, and you have to find the first occurrence index of first occurrence of sad, which is pattern string. So you can see that here index 0 is the index of first occurrence of sad, and I'm going to return 0 as my output. Now what if my string is something which is but? So in that case I'm going to return this index, which is 0 1 2 3. So 3 is going to be my output in that case. I hope you guys got the idea behind what basically the KMP algorithm is about. So I'm just going to move to the solution now. In the solution, I will start by explaining what exactly this problem is about. So this problem is a problem of pattern matching. Pattern matching. What is pattern matching? Pattern matching is the process of finding a pattern in a string. So basically I will have a string. Let's take a sad but sad, and I'm also going to take a pattern. So this pattern is something which is sad. Now I have to find this pattern. I have to find this pattern in this string. So this is what pattern matching is all about. Here we can have different patterns as well, like this pattern can be UTS instead of this sad, and even this pattern can be ABC. So if pattern is not present here, then we have to return something which is -1, like present is not found. So now what I'm going to do is, first of all I'm going to explain you the Knuth algorithm, which is also used for pattern matching. So I will start with the Knuth algorithm. This Knuth algorithm says that, hey, what you can do to find the occurrence of pattern is you can okay, so let me first write the string here, like I have sad but sad, and I have one pattern which is UTS. So the Knuth algorithm says that if k is the length of this pattern, like let's say the length of this pattern is length equals to k, and for this string length equals to n. So what I'm going to do is I'm going to check for every window of size k, like is this equal to my pattern? No. So I'm going to move this window here. So is this equal to pattern? No. Then I'm going to move my window here. And is this equal to pattern? No. Then I'm going to move my window here. Is this equal to pattern? No. After that I'm going to move my window here. So it is something which is like sliding window concept, where we check for every window that, hey, whether you are equal to my pattern or not. So if it is equal, then I'm going to return that particular index, or true, that my pattern is found. Else if I have not found this pattern in the whole string for every window, then I will return something which is false. So this is about the Knuth algorithm, and this algorithm is something which is which will have a time complexity of O of n cross k. Why n cross k? Let me just explain you. What we generally do is, like, let me take some other example, str and a and b, and I have to find a b. So this is my pattern. So how can I solve it? What I'm going to do is I'm going to have two pointers, like I will have one pointer here, one pointer here. So I will check whether it is I, it is j. So are they matching? Yes, these character are matching. So I'm just going to move my j here and I here. After that I will check Whether these characters are matching, yes they are matching, so I'm going to move my I and J at this point, I at this point and J at this point. Whether these characters are matching, yes they are matching, so I'm going to move my J here and I'm going to move my I here. Okay, so after that what I'm going to do is I can see that these characters are something which are not matching. So what I can do now, I can do something which is I can move my J again to 0 and I can move my I to this index. By doing this, what I will get is I will now check for like this window, that are they equal. So yes they are equal, they are equal, they are equal, but again they are not equal. Then I will move my J at 0 and I at this particular index, and I will move by doing this process. So you can see that I'm doing some repetitive comparisons. Like if I have already compared these two for this window, then I'm again comparing these two for this window. Like the next window, I'm again comparing these two. So this is something with which is the problem with naive algorithm. So let me just even implement the naive algorithm. After that, I'm going to move to the KMP algorithm. So the naive implementation is quite simple. What I'm going to do is I'm going to start my window from. Okay, why I'm doing this? Because this says that you have to consider all the windows. So well, the for the first window the string is going to be, so I will write my string as like string value is equal to haystack dot substring from I to I plus needle dot length. So this is going to be my string of current window, and after that what I'm going to do is I'm going to check if my value dot equals needle. So needle is my pattern, and then I'm going to return I, else. Okay, so let me just remove this. Else I'm going to return which is -1. So this is the implementation of the naive algorithm. Let's just see whether it works or not. Okay, so you can see that it's working for the example test case, and let me just submit it. So basically this is the problem on lead code, and problem number is 28, and you can see that it's working. So it's 41% faster than online Java submissions. So now let me just move to the KMP algorithm now, and I hope you guys are clear whatever I have explained you here. The problem with the naive algorithm, like the complexity is something which is O of n cross k, because for every window of size n, it's checking for like for every window of size k, it's checking whether this particular window is equal to my pattern or not. So now I'm going to explain you again. Like I'm going to give you the intuition behind the KMP. So let me write intuition here. Now what I'm going to do is I'm going to take this string again a b, and my pattern is going to be this one. But okay, so now see what I'm saying. I will start my I from here and I will start my j from here. So are they matching? Yes, they are matching. So now just move to this point. So are they matching? Yes, they are matching. Now move to this particular index. Are they matching? Yes, they are matching. Now move to this index. So this point I find out that these are something which are not matching. So what I can do is I'm going to move my pointer j back to the starting position, and my pointer I to the next position, like from the starting position to next position. After that I'm again going to check. But the problem with this is if I have already compared, like since I have compared this much string, and I find out that this is matching with this one, isn't it? After that I move to this point and I start from this next index, and I'm again comparing this much part. But if I get to know that like is there any substring, is there any first part of this particular string which is equal to the last part, then I can avoid this comparison. Like you can see that for this string like a, I can observe that this first part is something which is equal to this last part. isn't it? So if I have already compared this first part in the first string, so I can avoid comparing this part, and I can just move to this part. Like what I'm going to do here is, I know that this part is something which is equal to this part because I have already compared that. I'm just going to move to this index. Like for 2, I'm going to the length of this part is 2, and I'm just going to move to this index, and I will not move my I. So I will remain at same position, and now I will compare these two. And after comparing these two, I see that these two are matching. So what I will do is I will move to next index. So I hope you guys are clear what I'm exactly trying to say. I'm trying to say that if I get to know, like for and this is just only for this pattern string. Like let me write my observation for pattern string. If I can find out the first part, like the first part is something which I will get if I am able to find out the prefix, which is which is equal to suffix, then I can avoid some comparison, no doubt. Then I can do something like okay, so then I can avoid some comparison. I hope you guys are clear whatever I have written here. So I'm saying that if I'm able to find out the first part prefix, which is equal to the suffix as well, so I can avoid the comparison of this prefix. So in order to, like, when I say that the prefix, then I am talking about the length of prefix. So what I'm going to say now is, if I'm able to find out the longest prefix, uh, which is equal to the suffix, then I can avoid maximum comparison. So let me correct this statement. I'm going to modify this statement as, if I'm able to find out the longest prefix, which is equal to the suffix, then I can avoid maximum comparison. Now I'm going to tell you, this statement is nothing but gives us an idea about the LPS array. So LPS array is something which says that, hey, you don't have to worry about the longest prefix suffix. I'm going to give you that, but you just have to like focus on the string pattern finding. So this LPS array is going to give me the longest prefix suffix. For now, I just want you to assume that this LPS array is like abstract, so I don't have to worry about the implementation. And I'm going to write here even, so I'm going to write like, consider LPS to be abstract, at least for now, like at least for now. So now what I'm going to write my string and pattern again. So let me write it. So my str was something a and b, and my pattern was a b. Now for this pattern, the LPS is 0 1 2 0. How I am writing this? Just focus here. I'm writing this because LPS for index 0 is like, for this string, LPS of index 0 says that for this string, what is the longest prefix and suffix that you have? So it says that I don't have any like different prefix and suffix. So for this, if I write prefix, so I will write a, and if I write suffix to it, then I will write a as well. But the problem is, it is not a proper prefix, so it should be a proper prefix. Why proper prefix means that I'm not going to consider the whole length, like a b for this string is something which is not a proper prefix. So like the whole length. Now what I'm going to do is, I'm going to talk about this length for index 1. For index 1, I have string AA, and for AA, if I write prefix and suffix, so I will write A as prefix and A as suffix, and I can see that these are matching. So this is something which is the longest length. No any longer length is possible. If I write AA, then again the case will be of proper prefix, so I'm not going to consider that, so I will write 1 here. After that, I will talk about like this much length. So this much length says that you have a string which is AAA, and this AAA has a longest prefix AA and longest suffix AA, which both are equal, isn't it? So I'm going to write here 2. After that, for AAAB, I see that there is no any like last character which is matching. You can see that this is and this A and D is not matching, so I'm going to write 0 here. Now, this was just a brief explanation about the long LPS array, and I'm just going to move to this important part again. So I have my LPS array here, and I have this string here. I'm just going to remove extra stuff. Okay, now I'm going to write here LPS again. So LPS is 0 1 2 0. Now I will start matching the characters. So initially I'm at the first character and I can see that they are matching, so I'm going to move at this position. At this position I can find that these two are also matching, so I'm going to move here and I'm going to just remove them. I can see that these are also matching, so I'm going to remove to next index. After that I find out that these are not matching, so what I can do is generally I move to the index 0, and for this I move to the next index. But here I'm going to avoid some comparison, because since I'm at this index 3, so I'm going to ask from this string, because this string is something which is already matched, isn't it? This string is matched, that's why I'm at this index. So now this string is matched, and I'm going to find out that I'm going to ask from this particular character that, hey, do you have any do you have any longest prefix suffix? If you have any longest prefix suffix, then just give me length. Just give me the length, so that I can use that length in order to avoid the comparison. So it says that yes man, I have some like characters which are matching for this string AAA, and the length is 2. So now you can avoid two comparisons, and here you can see that I'm going to avoid these two comparisons, and I'm just going to move at this index 2. So now my I is something which is going to become LPS of like my, if I call this index as I and this as j, so my I will become LPS of j minus 1. You can see. I hope you guys are clear with what I'm saying here. And what I'm now going to do is I'm just going to compare this and this character again. So when I compare these characters, then I found out that yes, they are equal. So I'm just going to move my I here, and I'm going to move my j here. After that I found out that again they are not equal here. So if they are not equal, then I'm going to ask from like this again, because since this whole is matching, so I'm going to ask, hey, can you please tell me again whether you have any prefix suffix equal. It will say, man, yes, I have some prefix suffix which are equal, and the length of this is 2. I will not tell you again. Okay, so now I'm just going to move at this index again, and I'm going to check for this I and for this j, like let me remove some. I'm going to again ask from this, is this and is this equal? Yes, these are equal. Then I'm again going to move my j to this index and I to this index now. And now I again find out that yes, they are equal. I mean, they are not equal. So what I'm going to do is I'm again going to ask from this one, and this will again tell me that I have length 2 prefix suffix equal. So now my I will be here and j will be here. So it again sees that these two characters are matching. So what I'm going to do is I'm going to move this pointer here and this pointer like here. Now it again notice that it is not equal. Like, it again notice that this a and this b is not equal, so it is going to again move my j pointer here, and my I pointer will now remain same. Okay, so this time it sees that this a and this a are equal, and it just moved j here and j I here, and it sees that this time this b is also equal. So now this b is also equal, and now my j will increase to this point, and it sees that there is nothing left to compare. So this time what I have is, I have compared my whole string, isn't it? So if my whole string is compared, then pattern is find at this particular index. But this is not the starting index, this is the ending index at which we compare the last element of this pattern. So what I'm going to do is, in order to get the starting index, I'm going to generally we return true or false whether pattern is found or not, but according to the problem we have to return the starting index. So I'm just going to return I, like, okay, so this is I, I'm just going to return I minus pattern dot length. Okay, so this is about the KMP algorithm. Till now, I have not told you, or I have not explained you how this LPS is being calculated. I have just explained you how KMP works if you assume this LPS to be abstract method. So now I'm just going to implement this method, and I'm just going to implement this method now, and let me just remove this code. What I'm going to do is, I'm going to assume that this LPS method is something which is abstract. So I'm going to have my LPS as calculate. So this LPS is something which is going to be equal to calculate LPS from needle. Needle is something which is our pattern, so I will rather name them as strn pattern. strn pattern. Now I have my LPS array, and what I'm going to do is, I hope you guys have noted whatever I have explained you, because I'm not going to switch between board and my screen again and again. So what I'm going to tell you is, I'm going to have my index I as 0, and I'm going to have my index j as 0. Now while my I is smaller than str.length, I'm going to do something. What I'm going to do is, if my str.caret I is something which is equal to pattern.caret j, what to do then? Then we are simply going to increase our I and j pointer. This is something that I have already told you, no need to explain again. And else, if they are not equal, so but before checking whether they are equal or not, okay, so let me even write, before writing whether they are equal or not, I am going to write one more thing. If my j is equal to pattern dot length, means we are done with all the comparison, that this is the time where we have found our string like pattern. So I'm just going to return I minus pattern dot length, isn't it? And else, if my like I is smaller than pattern dot length and my current character is not equal, so just write that condition. If my str.caret I is something which is not equal to pattern.caret j, at that time see what I have done in my board. What I have done in that case is, I was asking from like LPS of I was asking from the previous character that what is the longest prefix suffix you have. So j is going to be something equal to LPS of I minus 1, and this is something which I have even written here, like, okay, so this is something that I have already like written here, you can see that. So now my I is something which is going to become equal to, so now I'm going to write my I will be equal to LPS of j minus 1. There will be one more case as well, and this case says that what if your j is equal to 0? Because if j is equal to 0, then you can't do something like j minus 1, isn't it? So in that case, you are going to increase your I. And I'm even going to give the significance of this statement, like what if my j is equal to 0. So like for this string, if my first character is not matching, like I have B here and I have A here, so there is nothing to ask from the previous string because nothing is matched till now. So I'm just going to return increase my I in that case. So I'm not going to ask something from the string because nothing is matched till now. So this is what that's why I'm doing something like j equal to 0, then I will do I plus plus. And now when I'm at this position, I have completed the loop and nothing is found, then I'm simply going to return -1. Now I'm even going to like write the code for the LPS array. So let me just paste it for now. I'm pasting it because I have not explained you the how LPS array works. So I'm just going to I just want you to assume that that implementation is something which is abstract. Okay, so this needle is showing error because we have changed our string. So I'm just going to make it pattern. Now see whether it works or not. Okay, so it's showing calculate. The spelling of calculate is something which is not correct. Calculate pattern. Okay, let's see. It's showing like why it's showing this error. Let's just see. Okay, so if my for this test case it should give me the right answer, but okay, for this one it's working. For even this one, it why it's giving me -4. Okay, so let me see here. What I have is I have something which is like I equal to 0, j equal to 0. If my j is okay, so okay, if my I is smaller than string dot length and character at I and j are equal, then I'm going to increase my I and j. And if my j is something which reaches the like a length of pattern, then I'm going to return I minus pattern, no doubt. And after that, if my I is something which is smaller than okay right here string dot length and the current character is not equal, then I'm going to check if my j is equal to 0 or not. Okay, so let's check. Okay, here I have to change my j, not I, because j was something which was going to move, not I. Let me even write let me even explain you here. Okay, so why it's showing time limit exceed, just see here, like it's saying that if j is equal to 0, then just do I plus plus, and else do j is equal to LPS of j minus 1, then what's wrong with this? If like string dot caret I is not equal to okay, I'm not able to like find I smaller than if my like if my character at I and character at j. Okay, I'm writing here I, but I have to write here j. Let's see now. I'm having some small mistakes. So okay, so now it's working. You can see here, and let me just submit it. Okay, so it's working fine, and so this is how the KMP algorithm works. Till now, I have not explained you how this LPS array is getting calculated, but I have explained you if you have the LPS array, then how you can solve the problem. And the main this is even the main intuition behind the KMP. And now I'm just going to explain you the uh, LPS array, how to calculate LPS array. So now let me just try here. Longest prefix suffix, so this is nothing but longest prefix suffix. Okay, so LPS array, like I'm going to take an example, and with that example I will explain you how LPS is calculated. So if AAAB is something that I have, so I'm going to write the prefix and suffix. So A is first prefix, AA is second, AA is third, and AAAB is the fourth prefix. Now let me write the suffixes as well. So B is something, AB is something, and a like I have AAB and I have AAAB. So these are the prefixes and suffix. But there is something else as well, which is proper prefix and proper suffix. So proper prefix is something which does not include the full string. So when we say proper prefix, then I will exclude this. And similarly for the proper prefix suffix, so if I write proper suffix, then I'm going to exclude this. So this is what the proper prefix and suffix is. And when we talk about the longest prefix suffix, so we are actually talking about the longest proper prefix and proper suffix. Okay, so and the meaning of LPS is, meaning is, give me the longest proper prefix, like proper prefix, which is also a suffix or proper suffix. So for the string that I have written like AAAB, if I see for like, if I see for this one, actually LPS array is something which is an array. So it store like for each index, it stores that till this string, till string at index I, what is the longest proper prefix and suffix that I have. So for LPS 0, I have this string as A, and if for this A I write prefix and suffix, so I will write A and A, but this is not proper prefix and proper suffix, so I am going to write here. And you must note one thing, that LPS of 0 is always 0, it is a fact. Why it's a fact? Because the first character is always going to have the prefix suffix and not the proper prefix and proper suffix. So I'm going to write LPS 0 as 0. Now I'm going to start from this position and I'm going to check if like these character are matching. So what I can say that for AA I have string is matching. So like what I have is, I have this string like this prefix and this suffix which is matching, so I'm going to write 1 here. Now I'm going to increase my this index and the length that I have matched, so I'm going to increase my this length as well. Now I will find that these characters are also something that is matching. So it is saying that already have one A that was matching, and when I move forward, then I find out one more A which is matching. So now I'm having AA as my longest prefix suffix, and you can even see that AAA has this AA and this AA as prefix and suffix which is equal, and which is not proper. So I'm going to write 2 here. Now I will move to this index and my length has become 2, and this 2 signifies that this is the longest prefix suffix which I have till now. Now I see that these characters are not equal. When these characters are not equal, then I'm simply going to write here 0. But why I'm writing 0? Because there is no other possibility. But this part is something which is very tricky. So why this is tricky? Let me take one more example. So one thing that we have observed till now is, if like I'm going to have, actually what I'm going to have is, I'm even going to write the pseudocode along with the LPS. So if I have something like AAAB as my string, so I'm going to first my first step will be always LPS of 0 is equal to 0, because it's a fact. So just write it. Now I'm going to start my length with 0, because my length is 0 till now, and my index with 1. Okay, so now here I can see that if my 0 length will be pointing to this, and 1 index is pointing to this. So if my char at I is double equal to char at j, then simply do LPS of like j, because this is the first index that I'm going to write. For 0 I have 0, for j I'm going to write I, and I'm going to do j plus plus. But this I is something which is representing the length, so I have to increase I first, isn't it? I hope you guys are clear what I'm actually trying to say. So if they are equal, then I'm simply going to write increase my length first, and then I'm going to uh, store this length here. So here I will have 1 because this is something which is j, and now I'm going to increase my j. So now my j will point to this, and my I will something which is will point to this. So this is I and this is j. At this point again I find out that the character are equal. So what I'm going to do is again I'm going to do I plus plus. So I will have 2, and I'm going to store it at LPS 2 because j is 2, and then I'm going to increase my j. So now my j will come to this, and now my j is at this position, and I have I at this position. At this point I find out that a and b are not matching. What to do then? This part is something which is really tricky, and I'm going to take other example in order to explain this part. So let's take, I have a string like cb dot dot dot. There can be other characters in the middle, and at last I have cbcbc, and I have matched till this character, and my length is something that I have matched is 4. You can even see that the length of 4 is CB is the longest prefix suffix that I have till now. At this position I find out that this part is something like these characters something which are not matching. These are not matching. So what I'm going to do is I'm going to ask from this length minus 1 that what is the longest prefix suffix that you have. And what the intuition behind asking from this is I'm accepting the fact that these like I cannot have the longest prefix suffix till this index using this e, but this doesn't mean that I cannot have like using other prefixes as well, because here I'm going to ask from this 2, and this 2 says that till this string I have longest prefix suffix of length 2, and even this is true. Like if I write cb then I can see that this and this are equal. So it is something which is going to give me index 2. So I'm going to ask from this, and this means that my length is something which is going to become LPS of length minus 1. I hope you guys are getting the intuition why I'm doing so, because if this e cannot be included in our answer doesn't mean that we are not going to have a longest prefix suffix till this index. How? I'm going to ask from this b, and this is going to return me index 2. So now I will come to this index 2, and I find out that this character is matching, which says that hey, you can have the longest prefix suffix, and this longest prefix suffix will be nothing but length plus 1. Length is nothing but this I, so I'm going to do length plus plus I plus plus. Length was 2 at this point because this gave me 2, so now my length is 2, and when I do 2 plus 1 then I find out that it is 3, and now I'm just going to write 3, and for this whole string and the last index I find out that this is the longest prefix suffix which is matching, isn't it? So that's why I'm going to write here, and I'm going to remove this. You can note it if you want. So I'm going to remove this stuff. You can rewind the video if you want to note out. So what I'm going to return is else. What if my character are not equal? Then I'm going to do something which is length will become, or I will say I will become, because I is something which is representing the length. So I will become LPS of I minus 1. Quite simple, right? But what if my I is 0? If my I is equal to 0, then I cannot have like I minus anything like I minus 1, because it is going to give me array index out of bound exceptions. So if my I is double equal to 0, then no doubt I will have my LPS of j equal to 0, because nothing can be done then, and my like j will increase at that point. Else I'm going to do something like I equal to LPS of I minus 1. So this is what the pseudocode of LPS looks like, and I have even explained the LPS along with this. Now what I'm going to do is I'm going to tell you for this AAAB, like for this AAAB I have told you till 0 1 2, and for the last index I found out that these two characters I was at these two indices, and these two characters are not equal. So what I'm going to do is I'm going to ask from this. So it is going to give me 2, because index like till 2 I have the equal substrings, and what I do is, for this I move to this, I move my I to this index. So again this index is something which is not matching, so I'm going to ask from this one, and from this one when I ask from this, then this says that I have one length 1 which is matching, and length 1 I will get 1, and I again see that the character 1 at this j is not matching. So again I move my I to this 0, and I found out that this a and this b is something which is not matching again, and at last I have my I equal to 0. I can't do something like I minus 1, then this condition is going to be true, and this condition says that LPS of j is nothing but 0, because there is no any character which can match to this b. And that's how we get our LPS array as 1 to 1 0, like 0 1 to 0. So now I'm just going to implement my LPS function. So let me just remove this implementation, and I'm going to have something which is public int LPS, like let's say is calculate, and I'm going to have my string str. Okay, now just let me write. So okay, I've opened the wrong page, and let me just, okay, so I'm just going to quickly write the LPS function, because we are running out of time, like it's 41 minutes now. Okay, so let's wait for a second while it opens. And okay, so it has opened now, and let me just write the LPS function now. So LPS function is something which is like, I'm going to have an array LPS which will be str, like str.length. After that what I will do is I will have my like, okay, so even do something like n equal to str.length, and because this length is something which is going to be used again and again. Now I'm going to do my I as equal to 0 and j as equal to 0, which I've explained you already. So okay, one more thing that we have to do is LPS of 0 equal to 0, which is flat, and while my j is smaller than n, what I'm going to do is, if my character matching like str dot character I is double equal to string dot character j, this time I have to do something like I plus plus and LPS of j equal to I and j plus plus. If they're not matching, then I have to do like, if my I equals to 0, then I can't do anything. So LPS j will be equal to 0, and then I will do j plus plus. I'm not writing LPS j equal to 0, because the array is already filled with zeros. So now what I'm going to do is, I'm going to do something like I is equal to LPS of I minus 1. At the end I'm simply going to return LPS. Let's see whether it works or not. Okay, so let's check whether it works or not. Okay, so it's showing time limit exceed. Let me just see why it's giving me time limit exceed. So if my characters are equal, like, then I'm going to simply do this. Else I'm going to do, okay, if my I is equal to 0, then I'm going to do like j plus plus, and else I'm going to do I equals to LPS of I minus 1. Then why it's showing me the time limit exceed? I think it's not. Okay, so I'm starting my j with equal to 0. I should start from j equals to 1. Very important. Now let's see whether it works or not. So it's working for example test case, and let me just submit it. Okay, so you can see that it's working. And so this is all about the KMP algorithm that I have explained you, and I'm sure by watching this video you are able to understand what is the intuition behind the KMP algorithm, how it works, and how the LPS array is exactly calculated, and what is the LPS array. So this is all about this video. Thank you.